again, in order to write the equation for a line or be able to graph a line independently, I need to know two pieces of information. I need to know the slope of the line, and I need to know a point that that line goes through. Well, remember, the slope formula is the difference in the y-coordinates over the difference of the x-coordinates. So if I have a point that I'm going to call any old point x1, y1, and I have a second point that I'm going to call x comma y, this formula, instead of having the x2, y2, I'm just going to put an x and a y in these where the y2s and x2s are. And so I have y minus y1 over x minus x1 is equal to my slope. And again, I just switch sides here. I'm going to move the x minus x1 over to the other side by multiplying both sides by it. And I get the following equation. Y minus y1 equals the slope times x minus x1. This equation right here is probably the most useful equation if you're trying to get information based off of verbal models from a graph or looking at a graph to be able to write the equation for a line. So this is called the point slope form. And if I just ask you to write an equation for a line given a slope and a point, you can leave it in this form. However, there are going to be a lot of times they're going to ask you to write the equation, solve for y. So I'm going to do some examples. I want to write the equation of a line that has the slope of 2 and goes through the point 3, 7. And this just becomes a straight substitution problem. I'm going to copy the y and I'm going to copy the x because I have to have an x and a y in my equation for a line from our definition of the general form. So I'm going to go y and subtract the y-coordinate equals the slope times x minus the x-coordinate. And again, if I just say write the equation for that line, that would be good. If I ask you to solve for y, we've got two more steps. The first one is we're going to distribute the 2 in. So I get y minus 7 equals 2x minus 6. And my last step would be to add 7 to both sides. So I get y equals 2x plus 1. There is a special case. And that special case would be if the point I was going through happens to be on the y-axis. And if that point that I'm going through is on the y-axis, my point would have a 0 for the x-coordinate, and I'm going to put the letter C for any constant on the y-axis. And we're going to take this point with just a slope equaling m, and we're going to take this information, put it into this equation, and we will come up with another equation for a line, or another type of equation. So again, it's going to be y minus the y-coordinate equals the slope times x minus the x-coordinate. I'm going to do the same thing. I'm going to rearrange it and solve for y. So I get y minus c equals x minus 0 is x, and m times x is just mx. And then I'm going to add this constant to the other side. And if you remember what that c stood for, it was actually the y-coordinate of a point on the y-axis. And so what this is telling me is, hey, I've got a slope. I've got a line that has a slope of m, and that crosses the y-axis at this point. And instead of using c for a constant, a lot of time you will see this equation written as y equals mx plus b, where, again, m is the slope, and then b is the y-intercept. Okay? Now, the point-slope form is the best form of the equation. The slope-intercept form only works if you know what the y-intercept is. And there are going to be some times you're going to be analyzing graphs that you're in the thousands or so for the x's, and there's going to be no way you're going to be anywhere near the y-intercept. But if you have the opportunity to use a y-intercept, you could directly calculate your slope and use the y-intercept to come up with the equation for that particular line.